All right, here's the video for notes 8-4, calculating sample sizes. So we know how to calculate confidence intervals for certain levels of confidence based off of certain values. But in this lesson, we're going to talk about how to calculate a particular sample size if we want a desired margin of error. So in this problem, it says researchers would like to estimate the mean cholesterol level mu of a particular variety of monkey that is often used in lab experiments. They would like their estimate to be within 1 millimeter per deciliter of blood. So they're giving us our margin of error of the true value at a 95% confidence interval. So as a previous study involving this variety of monkeys suggests that the standard deviation of the cholesterol level is about sigma equals 5 milligrams per deciliter. Obtaining monkeys is time consuming and expensive, so the researchers want to know the minimum number of monkeys they need to generate a satisfactory estimate. Okay, so in this problem, we know that we're dealing with means because throughout the problem it says means multiple times, and we know that we calculate the margin of error for means as the margin of error equals, so we have to decide if we're going to use Z star or T star, but remember that T star relies on your sample size, and in this problem, we are calculating the sample size. We are also given sigma, so we're going to assume we're going to use Z star for this since we don't know the sample size. It's going to give us our most conservative estimate. Sigma over the square root of n. So in this problem, we're given certain things. We're given our margin of error, so our margin of error that we want. It says here that this is our margin of error. However, we know that we want our estimate to be within 1 milligram per deciliter, which indicates that our margin of error is equal to 1 milligram per deciliter. In this problem, we're not given Z star, but remember Z star relies on your confidence level. So since we are doing a 95% confidence level, that means Z star is going to be 1.96. And then we are given sigma in this problem. Okay, so this is just going to be a pretty algebra heavy task. Okay, so let's plug in the information that we know. So plugging it into our formula, our margin of error is equal to 1. So it's going to be 1 equals 1.96 times our standard deviation over the square root of n. So in this problem, we're solving for our sample size. All right, so first thing we're going to do is we know that we need to get n by itself. So what we're actually going to do is we're going to take the reciprocal of both sides. What this is going to do, it's going to get n on top. So reciprocal of both sides to get the square root of n on top. So when we flip this, it just becomes 1 over 1. And then we have the square root of n over this. So I'm just going to actually leave it. I'm not going to put anything in my calculator until the very end, until I've solved for n. Okay. Next thing we're going to do is to get n by itself is we're going to multiply both sides by this denominator. And remember what these numbers represent is Z star times sigma. So I'm going to multiply this side by 1.96 times 5, and I'm going to multiply this side by 1.96 times 5. So that gets rid of our denominator here. So then what we're left with is 1.96 times 5 over 1, so it's just 1.96 times 5, equals the square root of n. And the last step to get n by itself is you have to square both sides because that's how you're going to undo the square root. So square both sides. So then we're left with n equals, and then we have 1.96 times 5, and that entire thing squared. So that's what we're going to put in our calculator. So 1.96 times 5, and that entire thing, that quantity we're going to square. So we get 96.04. The thing with sample sizes, so we're going to put this in the calculator. The thing with sample sizes is you should always round up. If we were to plug in 96.04 into our original thing here, so for the margin of error, so if we do 1.96 times 5 over the square root of 96, That's going to give us a margin of error of 1.0002. But if we do the same thing, but plug in 97, we have a margin of error of just under 1. So remember that we want our margin of error to be within 1 milligram per deciliter. Since this number is just over 1, that's why we're going to always round up for our sample sizes to make sure that we are under the margin of error that we want. So we're going to always round up. So we need 97 monkeys. So in context, I'm going to say we need 97 monkeys to be within 1 milligram per deciliter of our estimate at a 95% confidence interval. All right, so let's look at the second one. So in the second one, this is a problem about proportion. So let's highlight the important information. So it says that we want our estimate to be within 3%. So that's our margin of error. It gives us our confidence level, and it gives us P. So in this problem, we don't have P hat, so we can just substitute in for P. So we know this problem is about proportions. And we know to calculate our margin of error for proportions, we always use Z star times the square root of P hat times 1 minus P hat over N. However, in this problem, we're given P. So if we're given P, we're just going to substitute that in. All right, so in this problem, let's see what they give us. They do give us our margin of error. Make sure we write it as a decimal is 0.03. We're not given Z star, but we can get Z star based off of the 90% confidence interval. So that's going to be 1.645. And then in this problem, they tell us to use P of 0.5. All right, so plugging in into the formula, I have 0.03 equals 1.645 times the square root of 0.5 times 1 minus 0.5 over N. So just like the previous one, we're going to solve for N. So first thing we're going to do, the first step is going to be a little different, is we're going to divide by 1.645. So divide by, and that value is Z star, okay? That's going to get rid of it here. And what we're also going to do, we're actually going to go ahead and simplify this number just because a numerator here is usually going to be a pretty straightforward, simple number, easier to work with than this parentheses. So I'm going to say simplify, and that value is P hat times 1 minus P hat, or in this case, P. Okay, so on the left-hand side, we have 0.03 over 1.645 is equal to the square root. Well, if we do 0.5 times 1 minus 0.5, we should get 0.25. Okay, so the numerator here is going to be 0.25 over N. All right, next step, to get rid of the square root, we're going to square both sides. So I have 0.03 over 1.645 squared is equal to 0.25 over N. Okay, next thing, we need to get N on top. So what I'm going to do is I'm just going to take the reciprocal of both sides. To get N on top. Okay, so inside the parentheses, it's just going to flip. So 1.645 over 0.03 squared is equal to N over 0.25. And then the last thing we need to do to get N by itself is we're going to multiply both sides by 0.25. So multiply by denominator. And that denominator, just so we remember where that number came from, is P hat times 1 minus P hat, or in this case, P. Okay, so what we have is 0.25 times 1.645 over 0.03 squared. So that's what we're going to put in our calculator. So we get 751.67. And since we know that we always round up, we're going to need 752. And so we're going to interview that many customers. So in context, we would say, in order to get an estimate to be within 3% at a 90% confidence interval, we need to sample 752 customers.